Hi guys, last week we were learning to create equivalent fractions. We could take a fraction, like 1/2, we could split it into equal parts and create a fraction that was exactly the same size. So whether I get half a bar of chocolate, or 2/4 of a bar, or 3/6 of a bar, it doesn't really matter because I'm getting the exact same amount of chocolate each time. Understanding equivalence is the key to understanding fractions as we go through school. Whether we want to add, subtract, multiply or divide fractions, understand decimal numbers and percentages, or simply compare fractions. If we understand equivalence, we're going to be able to make connections in our learning, and we won't have to rely on memorising processes that we often don't understand. Today we're learning to compare fractions, and we're going to use and develop that understanding of equivalence in order to help us. To begin with, let's get thinking. I want you to consider whether you think the following statement is sometimes true, always true, or never true. A half is bigger than a third. Pause the video for a few minutes, discuss your thoughts with a partner, justify your thinking by giving reasons, and then share those with the rest of the class. You might want to use drawings or bits of paper in order to help you. Let's consider this statement together. Let's begin with a full bar of chocolate, and let's start by taking half of that bar. When we halve a bar of chocolate, we split it into 2 equal parts, and we're interested in one of those parts. Next, let's take a third of that bar of chocolate, and when we take a third of a bar of chocolate, we split it into 3 equal parts, and we're interested in one of those parts. So there's a third there. So in this case, you can see that half a bar is bigger than a third of a bar. So we can say that statement is true. A half is bigger than a third. But is it always true? This time, let's consider 2 different bars of chocolate. You can see we've got a small and a large bar of chocolate. Now here, if we take half a bar of chocolate, you can see that that half bar is considerably smaller than a third of the larger bar. So in this case, the third is actually bigger than the half. When we're finding fractions, it's always a fraction of something. If it's the same thing we're comparing, so 2 similar bars of chocolate, then a half of that bar is always going to be bigger than a third of the bar. But we don't necessarily have to be comparing the same thing. And in the second scenario, because we had a larger bar and a smaller bar, that third of the larger bar was bigger than the half of the smaller bar. So Yoda's statement is only sometimes true. It's time to get investigating with a partner. I've got 3 problems that I'd like you to have a go at together. Batman and Emma are running a lap of the track. Batman is 1/4 of the way round. Emma is 1/3 of the way round. Who is in the lead? And the second problem, Rocket and Buzz both want a glass of juice. Rocket pours 3/4 of a glass. Buzz pours 3/5 of a glass. Who pours more orange juice? And then the third problem, Ned and Han each have a chocolate bar. They eat some of their chocolate and Ned has 4/6 of his bar left, whereas Han has 5/12 of his bar left. Who has more chocolate left? As ever, I'd like you to use resources like fraction cards or maybe a fraction wall in order to solve these problems, and then draw pictures to prove and justify your thinking. Pause the video for 8 to 10 minutes, have a go at each of those, and then share your thoughts with the rest of the class. Let's discuss that first problem. Batman and Emma are running a lap of the track. Batman is 1/4 of the way round. Emma is 1/3 of the way round. Who is in the lead? So let's take Batman and Emma, and let's draw a bar to represent one whole lap of that track. Batman is 1/4 of the way round. So we can take that bar and split it into 4 equal parts. We can see that Batman has run 1/4 of the track and he's still got 3/4 to go. Let's look at how Emmett's done. He's run 1/3 of the track, which means we're going to split that bar into 3 equal parts to make thirds. He's run one of those thirds and he's still got 2 of the thirds to go. So now we can compare how far Batman has run with how far Emmett's run. Because we split that bar into 4 equal parts to begin with, we can see that each of those quarters is smaller than each of those thirds. 1/3 is larger than 1/4, so Emmett is leading the race. Let's discuss that second problem. Rocket and Buzz both want a glass of orange juice. Rocket pours himself 3/4 of a glass. Buzz pours himself 3/5 of a glass. Who pours more orange juice? Again, let's draw bars to represent the whole amount. And in this case, the whole amount would be the whole glass. Now, Rocket doesn't fill the glass, he pours 3/4 of the glass. So let's split that bar into 4 equal parts. We've made quarters. 3 of those quarters is filled with juice, so we've got 1/4 left over. Let's do the same for Buzz. Buzz pours himself 3/5 of a glass. This time we're interested in fifths, so let's split that bar into 5 equal parts. 3 of those fifths are the juice, and 2 of the fifths are what's left. When we made quarters, we split the whole bar into 4 equal parts. When we made fifths, we split the whole bar into 5 equal parts. That means that those quarters must be bigger than those fifths. And because we've got 3 of each, we can see that 3/4 must be greater than 3/5, which means Rocket has poured more juice. Let's discuss that third problem. Ned and Han each have a bar of chocolate. They eat some of their chocolate, and Ned has 4/6 of his bar left. Han has 5/12 of his bar left. Who has more chocolate left? Once again, let's start by drawing bars to represent, in this case, the whole bars of chocolate. Ned has 4/6 of his bar left, so let's split this bar into 6 equal parts to make 6. He's got 4 of those 6 left, and he's eaten 2 of the 6. Han has 5/12 of his bar left, so let's split that bar into 12 equal parts to make 12ths. He's got 5/12 left, and you can see there that he's eaten 7/12. Now this time it's a little bit trickier. We've got 2 different types of fractions. We've got 6 and 12ths, so it's going to be trickier to compare these. We've also not got the same amount of each. We've got 4 of the 6 and we've got 5 of the 12ths. So this time we can't rely on the fact that we know the 12ths are smaller than the 6ths because we've got a different amount of each. So this time we're going to need to try something different. We're going to use that understanding of equivalence that we developed last week. Each of those 6ths could be split into 2 equal parts. And when we do that, we've created 12ths. We can see that 8 of those 12ths are exactly the same as 4/6. But because we've changed Ned's chocolate bar into 12ths, we can now easily compare that with Han's chocolate. Ned has 8/12 left and Han has 5/12 left, which means that Ned has more chocolate left over. It's time to discuss our success criteria. How did we achieve success? What are the steps that we can go through to compare fractions? So pause the video for 2 to 3 minutes, discuss that with a partner, and then share your thoughts with the rest of the class. When we want to compare fractions, the first thing we can ask ourselves is, are the fractions the same type? So here you can see we're comparing 3/4 with 2/4. They're both quarters, and because they're the same type, then we can compare the fractions easily. We can see that 3/4 is greater than 2/4. But what if they're not the same fraction type? Well, in this case, we can ask ourselves, are the number of parts the same? Here we've got 3/4 and 3/5. We're dealing with 2 different fraction types. We're dealing with quarters and fifths, but we've got 3 of each. And we know that quarters are larger than fifths. So in that case, we can compare those fractions once again. 3/4 is greater than 3/5. But what if they're not the same fraction type and we've not got the same number of parts? This time we're going to use equivalence to help us compare the fractions. Here we've got 4/6 of a bar, which we're trying to compare with 5/12 of the same size bar. We can split each of those 6 into 2 equal parts so that we've got 12ths. 4/6 is the same as 8/12, so we can compare those and we can see that 8/12 is greater than 5/12. It's time to try that out. Can we apply that success criteria in order to solve the following problems? As ever, there are 3 options for each of the questions, and I want you to choose the option that suits you best. So for question 1, I'm going to use the yellow fraction. Lisa and Groot both have a carton of apple juice. Lisa has 2/3 of her juice left. Groot has 1/3 of his apple juice left. Who has more apple juice left? For the second question, I'm going to use the green fraction. Luke and Ron have a penalty kick competition. Luke scores 3/4 of his penalties. Ron scores 3/6 of his penalties. Who scores more penalties? And for question 3, I'm going to use the red fraction. Gamora and Tin Man are both reading the same book. Gamora has read 3/5 of the book. Tin Man has read 5/10 of the book. Who has read more of the book? Remember, I don't want just an answer to this. I want you to use resources like fraction cards or a fraction wall to solve each of those problems, and I want you to draw pictures and bars in order to prove how you've worked it out. If you finish within the time, why don't you have a go at making up 3 problems for somebody else to analyse and solve? Pause the video for 10 minutes or so and have a go at those. It's time to reflect on today's learning. So with a partner or as a class, I want you to discuss the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'm going to ask you to do today is, can you apply what we've learned? So as a class, I want you to discuss, analyse and solve the following problem. Martin, Lucy and Peter are all cycling from Ayr to Troon. Martin is 3/6 of the way there. Lucy is 3/4 of the way there. And Peter is 5/12 of the way there. Who is leading? And can you put all 3 of them in the correct order? Thanks for joining me again today. I hope you enjoyed that. As ever, if you've got any questions or you'd like to share your solutions, you can contact me at scott.morrow@southayrshire.gov.uk, and you can follow me on Twitter @scottmorrowsa. Next week, we're going to be continuing with fractions when we're going to be looking at counting and adding fractions. I hope you can join me then.